A big round of applause here.
Thank you very much. So we are from Wix. It's our first time at this Mobile Era conference, and actually our first time in Norway, and we are very excited to be here. Now, 3 years ago, Wix decided to write a new app, and decided to write it with React Native. Back then, React Native was a new platform, and there were just several developers working on the app. Today, we are getting closer to 100 developers, and during those 3 years, we learned a lot, and we want to share our experience with you. So in today's talk, we've split it into two parts. In the first part, we'll be talking about React Native, how it works, and how you can write good-looking apps with React Native. In the second part, we will describe our mobile app architecture, focusing on how to work with big apps, how to develop them so that how you can actually develop an app efficiently with many developers. We'll talk about the architecture, about our development and deployment process, and in the end of the talk, we'll try to answer the question, is it really working well to write a big app with React Native? So hi again, I'm Sergey. Before Wix, I spent several years working developing for iOS, and today at Wix, I lead the mobile platform infra team.
And hi, all. My name is Lev. I will be also doing the talk. At Wix, I'm a senior mobile engineer, and I also managing the operational aspects of the mobile guild. My background is mostly Android, and let's start. So before we dive into the React Native architecture and to our multimodal architecture, let's first define what do we want to achieve when we are building a big scalable application. In one sentence, we can say that we want to build a project that will enable us to grow without compromising on the development velocity. Meaning we want to be able to add more people to our project, to add more features, without compromising on the time to market of our product, how fast we ship the product to our end users. And we want to do all this without compromising on the quality of the application, meaning the performance of the app.
Let me tell you a bit about Wix product. So Wix.com is a platform for creating build sites. It's a platform for building websites. Now, our mobile app allows managing those websites, but not only. You can download the app and build what we call a digital place where you can grow a community or a business. Now, websites and digital places suit many different needs. For instance, you may want to open a digital place for managing a store, or maybe you want to write a blog. Or maybe you're a yoga teacher and then you want your students to be able to reserve classes or to talk with you via chat. So there are many different needs in the application, and the application is very big. To make it easier, we divide it in mini apps, but the thing is that the app is really big to serve all those needs.
So our first section of the talk will be about React Native. And the first thing to understand React Native, we will look on the native development world. And looking on the native development world, a company that wants to create a product, a good product, targeting to the three main front-end frameworks, Android, iOS, and web, need to maintain three different teams, such as in each team, there are experts from different fields. And there is two main problems with this model. First of all, they cannot share code between the teams, although they implement the same business logic, the same functionality. And the second problem, even maybe more important, is that we cannot share resources between the teams. because it's rare that a developer will be proficient in Android development and also in iOS development. So most of the companies, they have to compromise, and they can compromise on several things. They can compromise on time and money and really maintain 3 different teams. They can compromise on one of the frameworks and platforms, and first develop, for example, iOS application, and after that catch up with Android and web, for example. Or they can rely on cross-platform solutions, that some of these solutions compromising on the quality of the result. And for example, solutions that are based on WebView, trying to simulate native views with JavaScript, and the result is not very good. And a few years ago, guys at Facebook realized the same problem, and they decided to develop React Native. It was finally released to open source around 2015, and the main idea of React Native is that it enables us developers to implement applications with JavaScript and React, targeting different platforms, but still using the native UI building blocks. And in such way, we can use React Native for many platforms. And it's mostly known for Android and iOS, but it's also, we can write with React Native for other platforms like Windows, Tizen, Ubuntu. It's an experimental project, but it's possible. To demonstrate the idea of React Native and how does it work, we will take a simple application with a single image view, a Norwegian flag. And in React Native, we define our UI layer using a syntax called JS6, which is actually syntactic sugar over JavaScript. And what is important to understand here, when we define here an image view, image component in JS6, the actual class that will be responsible for rendering the image on the screen and for the user interactions is the same image view from Android SDK and the UI image view from iOS SDK. To understand how this magic works, I need your focus on the next 2-3 slides. So we need to dive inside React Native, how React Native actually built. So we want to be able to invoke methods from Android SDK and iOS SDK. And actually, the first layer of React Native is implemented in native in Java for Android and in iOS and Objective-C for iOS. And it mostly consists of 2 types of components. Native UI views, which are actually wrappers around the native views from the SDKs, and native modules, which are everything that is responsible for non-UI functionality. For example, turn on the Bluetooth, get device info, or do some heavy work on a background thread. Above that, we have a C++ layer that connects us to the JavaScript unified API that exposed to the React Native developer that develops his business logic and defines his UI layer using React and JavaScript. Unfortunately, React Native does not cover the whole native capabilities and do not expose all the APIs from the Android and iOS SDK. But it is an extendable framework, and we can add a native implementation in Java and in Objective-C. Of course, we can do it also with Kotlin. And we can add a JavaScript API to expose this functionality to the business logic layer. So we have native code inside the React Native. And let's see how all this thing compiles. So our native code compiles as any native application. In this case, we are showing the Java case, but the same idea for Objective-C. Our JavaScript code going through a process called bundling, and eventually all the results are packed inside an APK. And when we install the application on our device and execute it, the native code will be executed as any native application, and the JavaScript code will be executed by the JavaScript virtual machine, because it is interpreted-based language. And now we have these two realms. We have the native code on the main thread and the background threads, and we have the JavaScript, our business logic, on a dedicated JavaScript thread. And we need a way to communicate between these two worlds. So for that, we have the React Native bridge, which enable us to invoke methods from native into JavaScript and vice versa.
Now, this is a very interesting idea of how to develop with JavaScript. Then you can develop faster, easier, but still to use native views. However, there's one thing about JavaScript that I think is the best feature of JavaScript and also the worst feature of JavaScript. It's single-threaded. And this introduces some limitations when you work with React Native. Now, I want to show you one example to demonstrate those limitations, and then to explain exactly what's going on there and how we can overcome this problem with when working with React Native. So let's try to animate the view in our previous example. And here you can see that we've added the line at the center animated.image, and we put there translate x and translate y properties. There's I'm not showing here all the code because we need to prepare those animated position values. There are animated values in React Native, and for clarity, we are not going into that. But it's quite easy to do. And now, if we run our code, it will animate the flag. So this works okay, but here's what can happen. Imagine that you have some heavy calculation task that you need to run in your business logic. So for instance, you have some data arrived from server, and now you need to parse it and to update your data structures. Now, if you're developing a native app, you never do it on the main thread. You always go and do it on the background thread and only maybe update the data structures finally, like in the main thread. But you don't put any heavy calculations on the main thread. You keep it free to allow very good UI. So in JavaScript, there's only one thread. So we cannot put it on the background thread, usually at least, not on JavaScript thread. So let's try to simulate this busy, heavy calculation task on JavaScript with some busy wait loop. And you can see that the animation became laggy. Obviously, you cannot ship such an application to your users, right? So what can we do about that? Before we see how to fix it, let's understand what exactly happening. So at the top of this screen, you can see the time frame with number of milliseconds, and it's for 60 FPS, it's about 60 milliseconds for each frame. So the first, at the time 0, JavaScript sends the position of the view to the main thread. And then the main thread positions the view itself, because it's like a native UI block. Then there's a new position after 16 milliseconds, and the new position is sent to the main thread, and only then it's updated in UI. You can see the result, and so on. Now, when the JavaScript thread becomes busy, there's no way it can send a new position to the main thread in time. So there are several frames missing, and then a new position is finally sent, but the animation becomes laggy. So the thing here is that we cannot move this heavy calculation task from the JavaScript thread. But what we can do is make the animation be controlled in the main thread. So the idea is goes like this. Let's send all the data at the beginning from the JavaScript thread to the main thread. Then the main thread will understand how to run the animation. It will run the animation, and when the JavaScript thread becomes busy, the view will still be moved by the main thread, and Now, how can you do it? So, in order to make it possible, main thread or native code needs somehow to understand how to animate that. So you can send, for instance, all the frames, all the positions in advance in that data, or you can send some function that describes how to do the animation. Today in React Native, there are like several different solutions to that. There's an internal native drivers that allow us to do it, and there are some community-based libraries like React Native Reanimated that allow to do beautiful animations on the native side with declarative programming paradigm. So we here use in our example, use native driver. We just need to set this property to true when defining animated values. And you can see that despite we still have those, that busy wait loop, the animation is now looking good.
Let's go over the important points that we need to remember when we are working with React Native. So first of all, we indeed can share code between Android and iOS, sometimes with the web. We have the very convenient way to work with our UI layer with the JSX. React Native comes with a feature called hot reloading, because most of our business logic is in JavaScript. We don't need to compile the native code each time, and then the development process is much efficient. We need to remember that JavaScript is single-threaded, and in some cases it's a bottleneck, and we need to work with the right paradigm and the right, for example, the declarative way of programming. And important to remember that React Native is relatively new framework, and it's still missing some dev tools and some best practices. And at Wix, we are putting effort and time to overcome these challenges by building some libraries and some best practices. And also at Wix, we are big fans of open source, and most of these challenges when libraries are not related to the Wix business logic. So we can open source them. And how many people here works with React Native or worked with? Oh, a lot. So I guess you're familiar with some of the libraries. For example, React Native Navigation, it's our navigation solution, Detox, our testing solution, and etc.
Okay, so this was about React Native, and this is an interesting framework. Let's see what we actually have built with this framework. So imagine that you want to build a big app. So you need, if you want to develop it relatively quickly, you need to hire many developers and let them work on the same app. Now, if you have many developers working on the same code base, it might be very inefficient. Like after probably 7, 8 developers, any new developer added to the team working on the same code base may just decrease actually the development velocity. So we need to go and make our app modular. Then we will have independent development and release cycle, and hopefully we'll be able to keep development process at high velocity. Now, how can you split a big app into modules? So it's sometimes very hard to separate some logic into parts, but there are two simple, straightforward practices that I want to talk about for a minute. One is just separate the product into independent parts. At Wix, we are quite lucky with that because our app consists of those mini apps that I mentioned, like chat, stores, and so on. And those mini apps already define us which module we should create. Not only, but usually, every mini app will be developed as a separate part by a different team. Now, and also actually any big app, if you look at it as a product, it's usually quite easy to say what can be separated from what. Now, another thing to do is to find common infra parts actually in those separated parts. For instance, in Wix, like many of our mini apps have to deal with photos and videos, and we've decided to create a new module to call it Media Manager and to put all the flows related to the video and photos management into that module. Then other modules can just use that module and not write the code accessing camera and so on. Now, when you split the app, you need to be careful to not oversplit, because if you have many modules, like too many modules, you might get another problems like dependency hell, or you might get such a complicated structures and no one can understand what's going on in the application. I think ideally the beta ratio is about 2 to 5 developers per module. So the idea is simple. Let's make several modules and somehow put it in the app. But we need something to glue them together. So in our app, we have entity that we call the engine, which is basically everything that is not the app itself, the modules, that is everything that is not in the modules. Then the engine is loaded with some configuration that tells it which modules to load and how to set them up. So let's see what's inside the engine and what goes to the modules. So the engine is the app itself, actually, so it's an entry point. And when it starts, it does some internal stuff, some initializations, and then it loads the modules according to the configuration that we mentioned. It also contains some infra code, which is helpful for the modules. For instance, we have a global object called engine, and our modules can call function in there, for instance, engine.bi.log, to send analytic events to our BI server. We also put all the native code and all the native dependencies inside the engine. And modules have only JavaScript code. And we do this to have the engine as a whole app. So the engine actually is shipped internally to the modules developers as a completed app. It has all the native inside. It's packed like it has APK and iOS app inside, and the modules can just run this app without running Xcode on Android Studio, and we just inject the JavaScript inside the app. That way we can load one module, or we can load all the modules and then get the final app. But if we want only load one module, we can develop this module independently of other teams and so increase our development velocity. Now, when we're talking about independent parts, we mainly should think about independent development process in them, but the modules themselves are obviously often still dependent. For instance, that Media Manager module that I mentioned actually is called all the time by other modules. So there are dependencies, and we need to, and let's see how we deal with them. So if you put code like this, just import module B from module A, we will not be able to run our application with just module A, because we will not be able to bundle the code, right? Because the import will fail if we don't bring that module B as a dependency. So we have a simple rule. We say no direct imports. Okay, no direct imports to other modules. But what can we do instead of that? We can use the engine as a proxy. JavaScript is a dynamic language and allows to call methods by their names. So we have engine.invoke function that allows us to call a module from another module, module method from another module. So module b.foo is somehow registered method, and it can be called from module A. Now, sometimes, like, it seems maybe that we solved the issue, but not really, because we only solved it now for compile time, for bundling the JavaScript. But then in the runtime, this will still fail because there is no module b.foo registered if we don't bring the module b as a dependency. And that's what we want to achieve for our independent development cycle. So how can we handle this? First, it's sometimes okay to just crash at this line. Why? Maybe this is a flow. There is a flow when someone hits, clicks a button, and that gallery with photos is opened. And if the developer doesn't actually currently develop this flow, they may be not interested in checking this, so it's okay to crash in that flow. But always it's not the case, and you can't crash. Then you might use defensive call. We have engine.isMethodRegistered function that checks if the method was registered. So we can wrap all our calls to engine invoke with this check to not fail, to not crash. This is also not always good, because sometimes you need some functionality actually. And in that case, you can always mock the dependency and write some temporary implementation and development implementation. Now, this was about how we call the method, and we have similar for components. But let's talk about how we can register a method or a component in the engine. So we can use a simple approach with engine.register function and just call engine.register, pass it the name of the method that we want to register or component, and the implementation, like the reference to the function. And we actually used this approach in the past, but it turned to be problematic at scale. For instance, here in this example, you can see that module A registers a method and then calls some method from module B. And module B does the same. So when you load all the modules, they will just, you will not know how to call them, in which order. It doesn't matter if module A or module B is loaded first, it will not work, because they expect the other module be loaded already, and those methods register already. So we cannot use this. The approach that we use today is this. We've defined a very strict API for our modules. And one part of that API is methods and components function inside the module definition. And the module should just declare all those methods that they expose to other modules. And these methods functions are called at the very beginning of modules loading the process. So no module can actually use them before they are all registered. You first call all the methods functions and all the components similarly functions in every module, and only then allow modules to run their code. Another interesting thing in that strict API that we defined is our lifecycle methods. So we have functions such as onLogin or onApp switch to background that notifies the module about some events happening in the system. And the interesting part about this is that this is the only way for the modules to know about those events. And we don't allow any other way, because we want to have a clear picture of what happens in those events. So this allows us to fix, to handle bugs very efficiently and to handle performance issues very efficiently. Because if something goes wrong at some point, it's very easy to see what exactly is going on in all the modules.
Okay, it's my part. Okay, so now we got this picture that a model can, a developer of a model can work only with the engine and the configuration that will load only his model. But we said in the beginning that in some cases we do need to add some native code and some native dependencies. So, but on the other side, we said that all the JavaScript code will be in the model and all the native code will be in the engine. So in case a module needs to add native dependencies or implement some native code, they will create a library, and this library will be brought by the engine. It's a bit contradict the idea of independent development process, but we prefer to do it like this because we want the JavaScript developers that are working on the modules to work only with the JavaScript and not to compile the whole native code on their machines. And yeah. Another interesting thing about when we split our application into modules, and it's a challenge, is how we preserve a unified UI across the application. We want to avoid a situation when each team will develop their own loader or their own save button. So we have a special team called the UI-lib team, and they develop a react-native-ui library, which defines all the UI components that we use in our application. Of course, this is also open source, and you are welcome to use this. And this idea increases our development velocity because now the developers that are working on the modules don't need to waste time on developing components, because we have a team of professionals, of experts in UI that are doing this in a generic way. So now that we understand the architecture of our application and how every developer can work independently, now let's look on the development process and how we release these modules to our end users, because we want to have this process also independent. So when a developer working on his code, eventually he pushes to GitHub, this will trigger a build. We are using TeamCity, and during this build we will test using our UI automation tools only flows that are in the context of this specific module. Eventually this package, JavaScript package, will be published to some Artifactory. Now when the developer and the product want to test their module as part of the whole application, they will tag this version with the RC tag, meaning release candidate. And this will create a configuration for the engine. And in that configuration, all the rest of the modules will be tagged as a production, meaning the stable version of this module. And only the new module, it's the new version of our module, the awesome module, will be tagged with RC. And then we will again build. Now we are building the whole application, and we are executing end-to-end tests that are crossing flows, cross-module flows. And the result of this will be a version with orange background, which means at Wix an internal version, and it will be published to the App Center for internal distribution. Now the QA team of that module and the product manager can test the module inside the whole application, and if they decide that this module is good enough to ship to the users, they will mark this module with a production tag, the same RC version. And this will create a configuration for the engine, so the all modules are tagged with production. And then the result of the build will be a production-ready version. In our case, it's a version with a purple background, and it will be uploaded to TestFlight and to Android console. And after a quick manual QA sanity, that we will test their use cases that we cannot test during the automation, our release manager will be able to release the version to the end users, to the App Store and to the Google Play Store. To summarize all this, let's try to go back to the question that we started from. Can we build a big scalable application with React Native? So, indeed we can share code between iOS and Android. and it's increasing our development velocity, and we can build an architecture that will increase development velocity and will create independent development and release flows. Quality is a challenge in the React Native, but with a strong infrastructure team and enough effort, we can overcome these challenges. Growth, we are continuously growing, and currently we are 87 developers working on a single application, and we are releasing a new version to production twice a week. Thank you very much for listening for the talk. If you have questions about React Native, about our architecture, you can find us around here and ask.